Greetings everyone. We will continue our discussion on object-oriented programming through C++. In the previous sessions, we have started about the virtual functions, and in this session, we will be looking about the abstract classes, and we will be completing those. What is the meaning of the abstract class and how to use them, and at last we will be looking at how you can use objects as other class members. So first, coming to the abstract class, in the previous session we have started about this discussion regarding abstract classes and pure virtual functions. So I told you about what is a virtual function and a pure virtual function. A pure virtual function in C++ is a virtual function for which we don't have any implementation and we just declare it. Okay, I told you we will be having a virtual function, and that virtual function will be placed in your base class, and in the particular virtual function we will be just having the declaration and we do not implement it. We will be having just the declaration part. Apart from that one, a pure virtual function is declared by assigning 0 to it. Okay, this declaration will contain the assignment of a 0 value to that particular virtual function declaration. Okay, so that those virtual functions which are just declared in the base class and we just give or assign a value 0 to it, we will be calling them as pure virtual functions. Okay, so a virtual function will be written in this manner where we will be having virtual keyword, then void, and we will be having the name of the function and we will be assigning it to 0. So as you know, this should be the base class of your particular structure. So in this base class we will be having the virtual function, and that virtual function is just having the declaration. There is no implementation part or the definition part, and we will be assigning it to 0. When you have this declaration part of the virtual function and you assign it to 0, and this particular function is present in your base class, we will be calling that particular function as pure virtual function. And a particular class which contains the pure virtual function, we will be calling it as an abstract class. So why we will be calling it as an abstract class? Why? Because these pure virtual functions are otherwise called as abstract functions, and any class which contains the abstract function we will be calling it as abstract classes. Okay. So a pure virtual function is implemented by classes which are derived from an abstract class. Okay. So what is the meaning of this? A pure virtual function, that is, you will be having your base class. Inside the base class you will be having your pure virtual function, and you know this will be having just the declaration part, will not be having any definition part, and any class which defines, which is having, that is, which implements the base class, that is, which derives the properties of the base class, and or these are the derived classes. So one of the derived class has to implement this particular virtual function. So a pure virtual function is implemented by classes which are derived from your abstract class. So these classes which are derived from your base class have to be implementing this particular pure virtual function. Okay. So this particular thing, base class, will be calling it as the abstract class. So abstract class will contain the pure virtual function, and the derived class has to implement this pure virtual function. They has to have the implementation part. So this is the declaration, and the implementation has to be present here. That is, you need to have the implementation here, and you need to have the implementation here. So all the derived functions should contain the implementation. Okay. So that is about your abstract class and pure virtual function. So this is an example of your pure virtual function and abstract classes. So as you have seen, this will be a class base class. Inside the base class you are declaring a variable x, and you are creating a pure virtual function fun, that is virtual void fun equal to 0. This is the pure virtual function or the abstract function, and you are having another normal method, that is getX method, which returns the value of x. Okay. So these are two functions you are having. One is pure virtual function and another one is the getX method, and this is your class base. And you are having a derived class derived, that is, it is inheriting the properties of the base class, and it is having its own variable y, and inside the public you are defining this particular pure virtual function. As you have known, the derived class how to define the pure virtual function which is declared in the abstract class. So this is the declaration here, and your derived class has to contain the definition or the implementation. Okay, so here is the implementation, that is void fun, and inside the definition you are just writing cout fun call, that is you are just writing a statement here, we are printing a statement. So this is about your derived class, and inside the main if you see derived d, you are creating the object for the derived class and you are calling the function d.fun, okay, which is present here, and it will print the particular fun is called. Okay, as you know, you are not declaring the function here, you are declaring the function here, and this is the definition part of this declaration. So this will become the abstract class, and this is the pure virtual function or the abstract function, and this is the derived class which defines the particular pure virtual function, and this is how you implement your pure virtual function and abstract classes. And you need to know what are the various properties regarding these abstract classes. So a class is abstract class if it has at least one pure virtual function. Okay, if you write one pure virtual function, then the particular class will become an abstract class. There is no, you need not have any other thing, just if you have a pure virtual function or more than one pure virtual function, we will be calling it as an abstract class. And the second thing you have to know as a part of this thing is, if you try to create an object for your base class without the implementation of your abstract function, that is, if you don't define this particular pure virtual function in your derived classes and you try to create an object for your base class, that is, what is the thing here you are having is, you are having the test class, and inside the test class you are having the pure virtual function, okay, and you are initializing it to 0, and if you are not deriving anything, that is, there is no derived class for this abstract class. There is no derived class for this abstract class. And if I try to create an object for this particular abstract class, at that time it will give you an error because you haven't given any implementation for your pure virtual function. So if you don't give the implementation part or the definition part for your pure virtual function, you will be getting an error when you try to create the objects of your abstract classes. So in this example, what you have done is, you have a class test and you are having a pure virtual function show, and there is a normal method getX method, and you haven't written any derived class here. Directly you have gone for a main, and inside the main I try to create the object for your text method. So when I try to create the object for the test method, you will be getting an error in this method. Compiler error cannot declare variable t to be an abstract type of test, that is, t is an abstract type. Why? Because that is an abstract class, so it will be an abstract type, because the following virtual functions are pure within test virtual void test show. Okay, the show method which you have written inside the test class is a pure virtual function, and there is no implementation for that particular virtual function. So that is why you will be getting an error when I try to create the objects for your abstract class. Okay, that is the first property you have to understand. When your abstract class, when those classes you will be calling as abstract class when you have at least one pure virtual function. And if you don't have the definition for that pure virtual function, you will be getting errors in this manner. So that is the first property of your abstract classes. The second thing is, just like normal virtual functions, you can have pointers and references of abstract class type. Okay, you have seen this one in your virtual functions where you can create references for your base classes. Okay, those base classes are normal classes, but here these base classes are abstract classes. So the abstract classes also can have those references and pointers. This is the second property. So how it will be done? It will be done just similar to what you have done in your virtual functions. Okay. So we'll be having the class base. Inside that you are having one pure virtual function. That is why this will become your abstract class. And you are having the derived class. Inside the derived class, I am having the implementation of the show method. So that is the derived class. And if you go for the main, inside the main, if I see base star BP is equals to new derived. That is what I am doing. I am first creating a base pointer. Okay. Next, I am creating the derived class object. Next, I am assigning that particular address to your base point. Okay. So now BP or your base class pointer can access the show method of your derived class. That is, it can directly access show method of your derived class. So this is the thing you have done in your normal virtual functions. Same thing is applicable for your pure virtual functions or abstract classes as well. Okay. The third thing you have to know is, so if you do not override the pure virtual function in the derived class, then the derived class also will become an abstract class. So what is this meaning is, if you are having the base class, inside the base class, if you are having the pure virtual function and there is a derived class, okay, actually you have to define this pure virtual function in this pure virtual function has to be defined in this particular derived class. If this derived class doesn't have the implementation for this pure virtual function, then this also will become an abstract class. Okay, already this is an abstract class. Why? Because the particular base class is having the pure virtual function. That is why we will be calling it as an abstract class. And if there is a derived class and that derived class doesn't have any implementation for your pure virtual function, then that particular derived class also will become the abstract class. What will happen if this particular thing will become an abstract class? Then if I try to create an object for this particular thing, then this also will be giving you an error. So there should be some derived class, okay. There should be some derived class which has the implementation of your pure virtual function. Okay. So until then, all the further hierarchical classes will become abstract classes. One of the derived class of this level should have the implementation of your pure virtual function. So if the derived class doesn't have the pure virtual function implementation, then it also will become an abstract class. So an example for this one, if you see, so there is a base class with pure virtual function show, and there is a derived class which doesn't have any implementation of the show method. Then if I try to create the object of your derived class, then I will be getting an error which will be saying it is also an abstract class. So one of the derived class has to have, not one of the derived class, the derived class which is deriving the properties of the base class need to have the implementation of your abstract class. Okay, sorry, need to have the implementation of your pure virtual function. If it doesn't have, then it also will become an abstract class. Next, how to solve this one? I need to have another derived class, that is class D1, which derives the public method. Okay, which derives your derived class. Then in that particular thing, if you write the show method and its implementation, then you will not be having an issue. So one of the derived class has to have the implementation of your pure virtual function. The next property about your abstract class is, an abstract class can have constructors. So you are having general abstract class and you can be having general constructors. So your abstract classes also can have constructors. So how? So we are having the base class. So base class is the abstract class here. So you are having one pure virtual function, that is virtual void fun equal to 0, that is pure virtual function, and your abstract class can also have your constructor. So inside the constructor, what you have done, I have initialized I value to x. So then there should be a derived class which will implement this function, if you, that is a pure virtual function. So there is a derived class. Inside the derived class I am having y variable, and the derived class also is having its own constructor with ij values, okay, and it is implementing the constructor of the particular derived class, and it is also implementing the particular function, that is pure virtual function. It is having the implementation which prints x and y values, okay. Inside the main class, if you see, when I try to create derived d of 4, 5, so what is happening? When I call derived d, so I am creating a derived object d with parameters 4 and 5. So 4 will go into I and 5 will go into j, okay, and 4 value will go into base of this particular I. So at this instance, this particular property will be called, that is your base constructor will be called, where x value will become 4, okay, and your y value will become 5. Y value will become 5. So, and when I call the function d.fun, then 4 and 5 values will be printed. So this is how you can use constructors for your abstract classes, okay. So your abstract class constructor is defined here, and the derived class constructor is defined here. So your abstract classes also can have constructors in this manner. So these are all the properties regarding your abstract classes. So the next topic you need to know about is whether you can have objects as the class members or not. So far you have seen the classes. So some class test. Inside the class you can be having your public, private, protected. Okay, you can be having your access modifiers, your public, private, protected, and whether any other class, for example, if you are having class new, whether you can have objects of this class inside another class or not. Whether can you make the objects as the members of another class or not. Okay, so this is about topic regarding objects as class members. You can have objects of other class in another class. So a class contains data members and member functions. An object can also be acting as data member for another class. So an object, okay, which is the object of another class, can also be acting as member of another class. So an example regarding this one, how to have these objects as members of another class. So initially you are having the same set of statements. Next you are having class marks class. Inside the marks class you are having private variables roll number and percentage R and O and the PREC. And you are having inside the public you are having one constructor which initializes roll number and percentage to 0. Okay, the constructor will initialize roll number and percentage to 0, and you are having one method, read marks method. So inside the read marks method I am taking the input of the roll number and percentage, that is you have to enter the roll number and percentage, and you are having print marks method which will print your roll number and percentage. It is straightforward. This is get method and this is set method and get method. This will take the input of your roll number and percentage, and this will print the roll number and percentage. So this is the marks class. Okay, whether you can have this marks class objects in another class. So I have to create the second class, that is student class. Inside the student class, what I am doing is I am having a private. Inside the private, if you see, you are creating an object for your marks class, marks objm. So inside the private I am creating your marks object. So since this is a member, since it's a private member, so the private member can be only used inside the class only. So you have created this object can be used inside this class only. So for this particular student class you are having a name member, okay, separate name variable. So inside the public you are having a method read student method. What is the read student method is doing? It is taking the input of your name, enter name and cin name, and objm dot read marks. So this object is calling read marks method. The read marks method is present in this particular marks class. Okay, the read marks method is present in marks class and that is called by the object. Okay, and there is another method, print student method. The print student method is first printing the name, after that it is calling the print marks method. So the print marks method will print the roll number and percentage of the particular student. So with this, what you are doing, you are creating a marks object inside the class of student. Okay, so with this you can understand that you can create objects of another class in another class. Okay, here you are creating the object of marks class in the student class, and you can use that object like just any other member you have in your class. So this is about your class members, that is objects acting as class members. So in this session you have seen about this is the main method what you have to understand. This is a student class. With this student class you are creating the object for your student and you are calling these two methods, that is the read student method and print student method. So those are straightforward. Inside the main you are going to call those two methods. So in this session you have seen about what are abstract classes and how to use your objects as members in this particular other classes. So far you have seen about various things in this part of your object oriented programming through C++. So you have seen about operator overloading, and then you have seen about type conversion, and the last part you have seen about the inheritance. In the next session we will be going for the further things you need to know about object oriented programming in C++. Thank you.